Good day, folks. Welcome to Bright Mind Academy, where we bring brilliance to every lesson. In today's video, I want us to look at multiple choice questions for an electrostatics topic. Okay, so yeah, without wasting any further time, let's just dive into it. Small identical spheres. Okay, they are identical or on insulated stands carry charge of negative Q and positive Q respectively. When the centers of the sphere are at distance d apart, the spheres exert an okay, my English is dying. An electrostatic force of magnitude F on each other. So we are told that the force that they exert on each other is Q, when now it is Q. This one has a charge of Q, and this one has a charge of 3Q. Divide by what? By d squared. This is the radius, right? It means now this force they exert on each other, it is the same as what? When I take this, it's going to be 3K Q divided by d squared. Okay, so this is the force that they exert on each other. F is equal to Q, that and that and that. But now we want to know that they tell us that the spheres are now made to touch and brought back to the same position. Now, if they touch, remember there will be a transfer of electrons. Remember, if they are attracting, right? If they touch, it means now electrons will move from this one to that one. Therefore, meaning there will be a transfer of charge. Then they will be back to their position. Meaning now we need to find their new charge. Okay? Their new charge will be negative Q, this one, plus 3Q. Then we divide that by 2. Then we get something like Q, 1 Q. Okay, so it means each now after contact, they now have what? They are now positive, okay? They are now both positive, but with respective charges of 1 and 1. So now let's try to find the new electrostatic force, okay? The new electrostatic force will be F is equal to, what is the charge of this one? It is 1. You agree with me? It's going to be just Q and Q. So it will be Q multiplied by Q divided by d squared, because they are returning to the same position. So now, when you compare this to that, can you see that this is the old, this is the new? Can you see that the old one, it is 3 times, we're going to say F of old is 3 times F new. Why? Can you see here? This part here, the KQQ divided by d squared is the same as this one, right? It's the same as that one. So now it means now I can substitute this KQQ divided by d squared here by what? By F new. So hence I'm saying now F old, it is equal to F 3 times F new. But now we want to know the magnitude of the electrostatic force with the spheres now exert on each other in terms of F. The new one, the new force after being in contact, it will be how much? So we'll say a new force with respect to the old one is going to be F divided by 3. So this is the same as 1 divided by 3 old. We know just old, it is the same as just F. Okay, so it means now the new will be 1/3 of the old force. So the most correct answer is B. Number 24. Three charged sphere XY, and Z, supported by insulated threads of equal length, hang from a beam as shown in the diagram below. Sphere X is negative, is negatively charged. Sphere X attracts sphere Y. Sphere X attracts sphere Y. So when it attracts sphere Y, it means sphere Y it is positive, but repels sphere Z. So it means sphere Z is negative. So repel, it means the signs are the same. So they say which one of the following conclusion is correct? Sphere Y is positive and sphere Z is negative. Very true. I do not go anywhere. That is the only correct answer I can encounter. Okay, without wasting any further time, the answer is A. 25. Particle P has charge Q. Particle P has charge Q and particle R has charge 2Q. They are separated by a small distance R. Which one of the following statement about the electrostatic force FPR the force that P exerts on R, and FRP, the force that R exerts on P, is correct. Remember now, if I'm having two charges, P, okay, let me say P and Q of charges, Q and Q to Q respectively, they exert a force on each other, right? When they exert a force on each other, that force, it is the same in magnitude, but opposite in direction. Can you see this one is right, this one is left? So it means now the force is the same. Okay, the magnitude of the force is the same, but now the direction is not the same. Meaning it means that force P, oh, this is not Q, is R. Force P on R, which is on the force P on right. So the force that P exerts on R, it is towards the left, then it will equal to negative force R on P, or vice versa. Okay, or you can say this one is negative, this one is positive. As long as they do not have the same sign. Let's check it, that option. Force P, no, it is not half. They are not exactly equal. They are not exactly equal. One should be negative. They are not double, but now it has a negative sign like that to show that they are the same equal. They are the same, but in opposite direction. The force that they exert on each other is the same, but in opposite in direction. Then I'm told that two insulated spheres, R and S, on insulated stand carry charges of Q and negative Q respectively, are placed at a distance apart. Okay, sphere R exerts an electrostatic force of F on S. Sphere R exerts a force of F on R. Then we know S will exert the same force of F, but in opposite direction. So they say to us, the two spheres are now brought together into contact, okay, and return to their original position. The magnitude of the electrostatic force that R exerts on S is now, okay, let's first find their charges, Q nu, because they were in contact again. So there will be a transfer of electrons from this one to this one. Remember, from the one that is more negative to the one that is less negative. Q nu is going to be Q minus Q divided by 2, which is 0. So it means they will have a charge of 0. Okay, they will have a charge of 0. Therefore, it means now there is no force that will be able to be exerted thereof. Again, therefore, it means now if their new charges is 0, new charges are 0, 0 coulomb like that, it means now there is no force that will be in a position of being exerted. So they say the two spheres are now brought into contact and return to their original position. The magnitude of the electrostatic force that sphere R exerts on sphere S now is how much? It will be 0, because now they do not have any charge. Okay, remember F is equal to K Q1 Q2 divided by R squared. If one of the Q's is 0, then everything will become 0. 27, two identical metal spheres P and R on insulated stands carry different charges. The spheres are brought together into contact and then separated again. Okay, if the charge of sphere R after separation is Q, and the charge of sphere then, or the charge of on sphere P after separation is, okay, now we need to know there are two identical metal spheres, right? They are identical, and P and R on insulated stand carry different charges. They are different. Okay, so if those charges are different now, the spheres are brought into contact and then separated again, right? Okay, if the charge on sphere R after the separation is Q, the charge on sphere P is 1. Or remember, after separation, the charge will be the same, okay? The charge will be the same. So here, remember, we calculated Q nu. It became 0. It was for both of them. Also, we calculated Q nu here before. Then we found it was 1Q, 1Q. It will be the same for both of them, okay? So the new charge will be the same for both of them, making A the most correct answer. 28, a small negative point charge Q is negative point charge. Okay, they told you it is negative point charge. We also have positive point charge, but this one is negative. It's situated halfway between two identical spheres P and Q, carrying identical charges as shown below. Carrying identical charges, okay, as shown below. Sphere P exerts an electrostatic force of F on Q. P and Q exert the force that P exerts on Q, it is F. What is the magnitude of the net electrostatic force experienced by the point charge? Okay. Now the point charge will experience what actually? Now, I want you to see this like this. If P exerts a force, or rather, P experiences a force due to Q going to the right, and then two point charge is situated halfway between two identical spheres, P and R, carrying identical charges. Okay, if the charges are identical here, okay, if the charges are identical, let's say it is negative and negative, or positive and positive. The question is, sphere P exerts a force of F on sphere. Sphere P exerts an electrostatic force of magnitude F on Q. Okay, sphere P exerts an electrostatic force of F on Q. Okay, so it means now this will be a repulsion force. This is the force that Q experience due to R. Okay, the force of R due on Q. Therefore, it means this one will also experience the what? The force of Q due to, okay, the force of P due to, okay, the force of Q on P. This one is not R. Where do I take the R? P, like that. Okay, there will be a repulsion force. So the question is, what is the magnitude of the net electrostatic force experienced by the point charges? The point charges, since well the forces are equal and it is exactly at the middle, the net force will be zero. Because now the net force will be opposing each other, they're off. Okay, the net force here, it is zero between the two. Why? Because they are moving in what? In opposite direction. Number 29. Two identical spheres P and Q carry charge Q and negative Q respectively. Sphere P exerts an electrostatic force of F on Q. Which one of the following represents the magnitude of the electrostatic force exerted by sphere P, or exerted on sphere P by Q? Okay, if P exerts a force of F on Q, it means Q will exert the same force on P. Okay, so the force should be the same, irrespective of the charge. Why? Remember Newton's third law. You apply a force on me, I apply a force on you. Just that it will be different in direction. But now they wanted the what? The magnitude. Number 30. The diagram below shows the field lines for the combined electric field due to small charged P and Q. P, when I check it, it is positive. So it is negative because, it is positive because they are going away. Okay, the electric field is going away. Positive for Puma. Okay, but here Q, it is negative, the angina. So I'm in a position of saying this is positive, this is negative. So which one of the following combination shows correctly the polarity of sphere P and Q? P, it is positive, then Q is negative. Positive and negative. D is the most correct answer for number 30. Two oppositely charged point charges. Okay, they are point charges. Move towards each other. Point charge, it is positive point charge, positive point charge. Okay, they are moving towards each other. Which one of the following is correct? The point charges move at a, okay, the point charges move at a constant velocity. No, remember there is a force that they exert on each other there. Okay, therefore, let me repeat that. Oppositely charged point charges or oppositely charged. Okay, so this is maybe positive point charge and a negative point charge, like that. So if they are moving towards another, they are accelerating towards another because they are still exerting a force on one another. Okay? So the velocity is not constant because now they want to attract, and now if the force between them becomes stronger. Okay, as I want you to see it like this. Okay, let's say the distance is 1 meter. As they move towards each other, the distance, maybe let's say it is 0.5 meters. Now, what is happening here? We know that when the distance is decreased from this formula, F is equal to K Q1 divided by R squared. When R decreases, the force increases again. So if now the force increases, what will happen? We know F net, F is equal to ma. Again, F is equal to ma. If now the force increases, what will happen? The acceleration will increase. Therefore, if the acceleration is increasing, it means the velocity is increasing. Okay. So now the acceleration will be zero in this case. Not decreasing velocity, constant acceleration. No, the acceleration increases. There's an increasing acceleration. Why? Because the distance decreases as they move close to one another. And if the distance is decreasing now, the force increases. Therefore, what will happen? According to F net is equal to ma. If the force increases, the acceleration also increases. Very, very important. A proton and an electron are distance r apart. The magnitude of the electrostatic force that they exert on each other is F. Which one of the following graphs shows the relationship between F and R? Remember, F is inversely proportional to R squared. So it means the graph I'm expecting, it is a graph that's like this. F and R squared, they are inversely proportional. C is the most correct answer. Okay, yes. This one was going to be if it is 1 divided by R squared, we're going to accept it like this. We never have a graph like this. We never have a graph that decreases like that. Okay. Number 33, two identical charges, sphere X and Y, carry charges positive 2Q and negative 6Q respectively. Sphere R experiences an electrostatic force F to the right when the distance between their centers is R. Now they say the spheres are brought into contact and then return to the original position. Remember, every time when it is like this, we need Q nu. Q nu is going to be positive Q minus 6Q divided by 2, which is negative 4, which is negative 2Q. So let's start and find the force first. The force when they were initially 2Q and 6Q divided by R squared is now F is equal to 2 times 6, it is 12, AQ1, Q, let me just say Q, let me name it Q1, Q2, Q1, Q2 divided by R squared. So the first was 12, Q1, Q2. Now let's see, now that they were brought into contact and now they have a new charge. So they now have a new what? Remember, electrons will move from negative to positive. Okay. So now the question is the sphere. Okay, the spheres are brought into contact and then returned to their original position. Remember, the minute they are brought to contact, there will be a transfer of charge from the one that is more negative to the one that is less negative. Therefore, you will need to find the new charge. Okay, the new charge. After finding it, then we find the electrostatic force and see how much it is. Okay, so they say which one of the following represents the magnitude of the electrostatic force that sphere X experiences now. So we're gonna say, okay, F is equal to now, okay, the charge now it is 2Q1, okay, 2Q2, okay. Can you see it was 2, it is now 2, not 2 and 6, okay. Remember, when you substitute into this formula, don't care whether it's negative or positive. The distance is still the same, both to the same position. Therefore, here, when I do my mathematics, I get F is equal to 4 Q1, Q2 divided by R squared. So this one is the first new. This is the new one. This is the old one. Okay, so we want to know, okay, what is happening. So can you see now that the first of old, it is 12. The first old, it is 12. The first new, it is 3. So when we say now, you need to say, okay, which one of the following represent the magnitude of the electrostatic force that sphere X experiences now? So we want to know new. What is the ratio between the new and the old? Okay. One thing I see is that I'll come back to the ratio. Force of the old, it is equal to 3 times force of the new. Why? Because when I say 12 divided by 4, this is 3 times again. So now force old is 3 times force or, uh, 3 times force of the new. Okay, so now force old is 3 times force or, okay, ka na wa re, 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now force old is 3 times force or, 3 times force of the new. Okay, so now for I have force new. No, it's fine. It's fine. 12 divided by 4. You'll say force old is 3 times force new. Therefore, we want force new. Force new will be force new is equal to force old divided by 3, which is the same as 1 divided by 3. Okay, so the most correct answer is B here. Or you can say, okay, okay, let me have force new because I want to know what is the magnitude of force new. Divide by force old. While do you agree with me? KQ1, Q2 is the same. Divide by R squared is the same. What will differ is that the number. The force new, it is how much? It is 4. Therefore, the force old, it is how much? It is 12. What is 4 divided by 12? It is 1 divided by 3. Therefore, they differ by the scale of 1/3. So the most correct answer it is B in that particular case thereof. Therefore, the last one, they say refer to the diagram below. Q and R are small spheres suspended by light insulated string. When a negatively charged rod is brought close to sphere Q is repelled. So if this is negative and this is repelled, it means this is also negative. When the negatively charged rod is brought closed, okay, when the negatively charged rod is brought close to sphere R is attracted. If this is negative, this means to be positive so that they can be, okay, remember unlike charges repel, like charges repel, unlike they attract. So which one of the following combination below can be possible for the nature of the charge or the polarity on the sphere Q and R? Q is negative, R is positive. Where is that negative and positive? Okay, I do not have negative and positive here. I get sharp. If that's the case, it means now, okay, let me see. Q is negative. Let me come here and say negative. P positive here. But can you see? Okay. Another thing what can happen is that this one is negatively charged, right? Sorry, when the negatively charged rod is brought close to sphere Q. So it means now to sphere R is attracted. Remember, sphere R has what? Has both positive and negative because it is a sphere. So it means sphere R now can have positive and negative. But when they, okay, let me come here. Oh, when this negative a rod come close to R, R will have a shift of a shift in electrons. These electrons will want to come, sorry, the protons will be on the side that experiences the what? The negative side. Okay? Okay? Yes. These negatives, okay, will want, if R is neutral, basically, if R is neutral, it means it has both equal number of protons as well as equal number of electrons. But now, if we bring a negative charge, there will be, I forgot the name that we use in grade 10, where there is shift in polarity. Okay, what will happen is that if it was like this, let's say it was like this, negative, positive, positive, negative, positive, negative, or let me just say, place them randomly. Positive, negative, positive, negative, negative, positive, positive, negative. If I bring a negative rod like this, what will happen is that the rod will still be negative, but now it will cause what? It will cause the positive protons or the protons to come into the side. Therefore, the negative will be repelled. Do you agree with me that the positive will be attracted, then the negative will be repelled? So hence now this one can also be attracted because this one will move to the negatively charged whatever rod, then whatever like that case. So it means now sphere R has a possibility of being neutral. So it has these options, neutral or negative like that. Okay, so yes. So the most correct answer in this case thereof, it is number G. Cool. Yes. So that's all from me for multiple choice questions under electrostatic force. So let's meet on the next video. I hope you enjoyed. Thank you.